Hello everyone and welcome back. This is the Philco 41280. I first showed you guys this radio chassis back about 7 months ago in a Friday night unboxing that I'll reference. It's for a friend of the family's. And it's time to do a little troubleshooting here. We're going to start out today with the speaker and take a look at the fill coil. Like many radios from this period, the Philco 41280 that you're looking at uses an electromagnetic dynamic speaker, again, which has the integrated fill coil. And again, I'm showing the fill coil on the speaker itself, and also we'll reference it here on the schematic in the picture-in-picture. Again, it's wound around the center pole piece of the speaker. In this particular radio, the fill coil has two purposes. Again, it creates that magnetic field that we need around the center pole piece for the speaker itself to work. And again, the voice coil itself would oscillate up and down. And it also acts as a filter choke. You can see here along with the electrolytic capacitor. So again, that helps filter out the AC components and also provides a cleaner direct current or B+ voltage to the remaining part of the receiver. Okay, you can see on the schematic again, the fill coil itself is called out at 1100 ohms or 1.1 K. And doing some DC resistance measurements, you can see here on my multimeter, we're not even anywhere close to that. So we need to do some troubleshooting here to understand why. Okay guys, here's what I elected to do. I've got my audio generator hooked up. I'm going to generate an audio tone at 700 Hertz. That's being applied directly here to the voice coil. And then I'm going to energize the fill coil using my power supply. And what I've done is put about 800 ohms of DC resistance in the negative side right now. And I just want to keep my current low and stay below 150 milliamps, which is the max for my power supply. And I'm going to try to run the DC voltage up to about 180 or so. That will match what I show on the schematic on the output side of the fill coil. So what should happen then is the amplitude of the audio signal that I'm pushing into the voice coil should increase as the DC voltage increases. Again, that center pole piece will become magnetized and allow the voice coil to move up and down. And again, we'll hear more loudness from the speaker. So first thing, let's power up the audio generator. So what you hear now is just the 700 Hertz tone. And again, that's just coming from the audio generator directly to the voice coil itself. And again, the voice coil checked good. DC resistance, not impedance, was just under 6 ohms. Okay, now I'll go back over to the power supply. Let's flip it on and we'll bring the voltage up slightly, and you can follow along here, and you'll see as the voltage increases, the amplitude of the signal itself will increase out of the speaker as well, or it should. And I'll try to keep my hand out of the way so you guys can see the current. I'm going to watch really close here the DC current. And you can hear what I'm talking about again as I bring the DC voltage up. The amplitude of the signal from the speaker is getting louder. Let's see if I can get up to about 180 volts and not exceed the current capacity of my power supply. Okay, I'll stop right there. Now you can see if I generate or rock the audio generator around, it sounds like this speaker is actually going to be just fine. Don't quite understand at this point why the DC resistance is so low. but we'll follow back up on that when I start cleaning around the voice coil and the frame. I'll do a closer inspection, and we'll remeasure everything as well and document that. But just to give you an indicator now, I'm going to flip the power supply off, which will kill the DC voltage to the field coil. And you can hear how the amplitude dropped, which is to be expected. Okay folks, thanks for watching this short video again on a little speaker checkout, and again applying some DC voltage to the field coil just to demonstrate how it works. Hope you found it helpful. Take care.